Hey everyone, in this video I want to talk about hit attributes, or a little bit also general attributes that happen when something collides in a pop simulation. Because we've already seen a few of those when we talked about the collision behavior. So a quick reminder, when we set our PopNet or pop collision behavior node to the stick response, then whenever a point sticks to a geometry like here, in this case a moving one, then the points that are stuck to our collision object, which is a static object of course, actually get an attribute called stuck. As you can see here, there somewhere there is a stuck attribute. So what we could do, for example, is we could use a color node and say whenever the stuck attribute is set to 1, and to make sure this actually works, make sure that your group type is points, then you can say, for example, those should turn green. There you go. And this is what we already saw. And the same is true when we have our response set to slide. Then we get an attribute called sliding that we can read out. So here I set my color to green for all the points with the sliding set to 1. And then we can see that all the still sliding points on the surface will turn green. So we've seen this before, just a reminder, because you could call this a hit attribute as well, because it is influenced by a collision. A similar thing is when we set our response to die, then we know, even though it might look a bit odd out of context, whenever a point is hitting another object, or a static object in our case, then it will die. Now this actually also creates an attribute, and this attribute internally is called det. You can see that it actually exists here. But for all the points that come out of our PopNet, this is set to 0. So let's quickly filter for the det attribute. It's all set to 0. And the reason is all the points that come out of here are still alive. But you can see that this attribute at least exists. Now, the reason why we never see an attribute with a value of 1 here is, of course, that the point will be deleted as soon as the det attribute turns 1. So why would you need that? We will see that in the next video. We can actually use that as an information during the frame, because basically between the beginning and the end of the frame, this det attribute still exists. We just don't see it as a result. So we can then later use that to, for example, as we will see, emit new points. But this is something for the next video right after this one, where we will go deeper into this. Just keep in mind, internally there is actually a det attribute, which outside of the simulation doesn't make sense, but inside of the simulation this actually serves a purpose. So now we want to talk about the classical hit attributes. Now, where would I find those hit attributes? Actually, by default, you might have already noticed them. They just come out of our simulation. If I just run something where there is a collision, so nothing special here, I have a sphere where my points are scattered from with a start velocity, and then I have a wall that they collide against, represented as a static object, and then just a collision happens. Nothing special, but what comes out of here are a lot of hit attributes. And this is something that you can actually turn on and off in the pop solver under collision behavior, where we change the response. And what we haven't talked about is that up here there is a checkbox called add hit attributes. So if for some reason you don't need them, you can turn it off. And you can also be more specific. When you open this attributes tab here, you can see all the attributes that are created. Now, not all of these attributes we will look into, because, some of them I've never used. I couldn't even come up with an idea what to do with this, but it's actually quite a lot that you can do. So for example, the hitNum attribute, well, hitNum sounds a bit like it's the number of collisions that happened so far, but that's not actually what this is. The hitNum attribute says if there is currently a collision or not, and if yes, if there are maybe multiple ones. So as soon as the collision stops, the hitNum attribute will be set back to 0. But let's quickly actually look at it. We could visualize this by just clicking on it. Here it is, hitNum, and let's make sure that we actually see it. Let's set it to marker. Yeah, there you go. And you can see it's 0 for all the points except this guy here, where it's 1, because that is a point that currently has in this frame a collision with exactly one object. So just keep that in mind. Maybe that's exactly what you need. We will use a similar one in a second, which is also there, which is called hit total. But we will look at this in a second. Let's have a look at other ones. Hit position, for example. So every point will actually save the position it had a collision at. So for example, again, let's visualize this. We can click here on hit pos, and again, we have to make sure that we properly see it in form not of color, which makes no sense, but as a marker. And here you can see, well, the starting points have a 0, 0, 0 because there is no hit position, but those points here that had a collision before, well, they basically carry the attribute where they had a hit position in space. So when we look at the hit attributes, here they are. And then when we specifically look for the hit pos, we can see it's just a position in space that is not changing as long as there is not a second collision happening. What you could use this for, I don't know. I never used it, but it's good to know if there is something that you could use it for, to know that it actually exists. What else? Similar, the hit normal. So this is actually the normal of the object that the collision happened with. So in this case, what would happen is you would get a normal in the x direction that would be saved. Actually, let's not just assume this. Let's have a look. It's called hit normal. Well, almost. It's actually NML. There you go. And you can see it's 1, 0, 0 because that was the normal of the face that the points collided with. Then we have hit velocity. That's interesting. When your collision object has a velocity, then the velocity of that collision object will be saved. Again, what you need that for, I have no idea. And then there's a hit time, which is also interesting because it saves the time when we look at it, hit time, of the time in seconds when the collision happened. So 0.0, which is somewhere down here, somewhere, this guy over there, and he had a collision after 0.11 something seconds. So I don't know, maybe this could be interesting for you to filter certain points that had a certain collision at a certain time. What else? Hit path. Well, that is unfortunately not as interesting as it may seem, but let's have a look at it as well. And as you can see here, this is basically an internal ID that is represented inside of our simulation. In this case, when we click on the static object, we can actually see that the internal object ID is 1. And this is what is shown here in the hit path. So it is a bit tricky to work with that because working with internal object IDs is rare. And what you would wish is that there's maybe a path to where the collision object originally comes from or something, but that's not the case. So it sounds better than it is, and this is why I wanted to show it to you. I was never really able to use it. What else do we have? We have something that we will actually look at, the hit prim attribute. And then also what we will look at is the hit UV attribute. But before we look at those, let's have a look at the one that we already talked about, which is actually the most common one to use, and that is hit total. And here's a good example what you can do with this. What's happening here is we have a couple of boxes as collision objects, and then we just have a source and the points are bouncing off these boxes like so. What you can imagine is that this now accumulates the number of collisions. So this is the first collision, second collision, third collision. And this is actually what we would see if we look at the result of the hit total, that in the beginning it's 0. And then as soon as the first hit happens, it rises to 1 for those points. And of course it goes to 2 after the second collision and 3 and so on. And we can actually use that to, for example, run an attribute adjust color, because what we could use here is a random color based on a color ramp. So I used here these default rainbow colors, and the randomization should be based on that hit total attribute. So I changed it to custom attribute, meaning that whatever the hit total is, the points will get a different color. And when I then copy some spheres onto this, you can see what you can do with this. You can actually, for example, change the color based on how often an object has hit something. Of course, you can do something more complex than that. I don't know, you could move it over a ramp directly via this number, so feel free to play around with this. But stuff like this is possible by just reading out the hit total number. And we will actually use this attribute in the next video for another effect. So hit total is pretty important. And again, what you could also use is hit num. The only disadvantage of this attribute is that it is not basically saving the number of collisions that happened, but only holds the information if there is currently a collision happening, which can be helpful, but in my opinion, hit total is a bit more useful. And then what else can you do with this? So one thing I had in production once, it was important to know what object we collided with. Now, as we've seen, you would think you could use hit path for that, but unfortunately that is really complicated and doesn't really help you about what object you actually collide with. So what we have here are just two spheres that I animated with a sine wave, so they just move back and forth. And then I made a couple of points that have a start velocity upwards. So if I copy a couple of geometry onto it, then the whole thing looks like this. The points shoot up and they collide sometimes with the blue sphere and sometimes with the red sphere. That's the setup here. So what I used here is the hit prim attribute. There it is. And as you can see, the first couple of points don't have anything, but then later each point saves what the last face it collided with. And we can use that as a way to find the object it belonged to. because by knowing the primitive, we can read out whatever the information was on that object. By the way, why don't I have a hit point? Well, because a point cannot really collide with a point of an object. It will always collide on the surface of the object in form of a face. So this is why SideFX chose hit primitive and not hit point. So this is why we have to kind of stay in the logic of primitives. And this is why, to make this work easier, I made sure that the colors are actually primitive colors. So the CD attribute is on the primitives. And if I want to use the hit prim attribute, I'm also promoting it from the points to the primitives of the spheres that I copy onto the points, so that I can stay completely with the primitives in this setup. So what I'm doing is I'm reading out the color from the hit primitive from my collision objects, and then take that color and put it as a color on my spheres. And then it looks like this. Whenever a point hits an object, it basically then steals the color of that object because it knows what face it collided with. I know this is a bit, long-winded to get this information, but again, the problem here is we can only read out the hit primitive. So we have to kind of move all the information and promote them so that we can stay in the primitive world, so to say. It is a bit annoying, but if you play around with this, you can see why this is necessary. But at least, as you can see, you can now read out all kinds of attributes from the collision objects. That doesn't only have to be colors, of course. It could be a class attribute. It could be, I don't know, any kind of attribute that you want to read out, and then you can move this over to your particle. So this is, my opinion, the most common way of doing something like this, using the hit prim attribute. Then the next one is a bit more rare, but it's also interesting, and that is you can actually read out the UV of your collision object. So the idea here is that wherever your particle hits your object, you can read out not the texture as it may seem here, but the UV information. So when we look at these points here, they just collide here with the surface collision, nothing special. But when they collide, they, with all the other hit attributes, also save hit UV. And here you can see now that on the points is the information what the UV was of my object. Now this by itself is kind of pointless, but what you can do then is when you put geometry onto it, and then I have to promote the hit UV, which again is on the points, but as we know, UVs have to be on the vertex. I have to promote it. And then what I can do is I can use that information, and with a UV quick shade, for example, could apply the same texture that I applied to my collision object, and it will read out the according color from that texture, because basically every point holds the UV information of where it collided with my object. So this can be interesting if you want to kind of steal the color of a textured object. So wherever a point hits an object, it will steal not the color directly. To my knowledge, that's not possible, but you can at least steal the UV, and from that you can then read out what the texture must have been. I hope that makes sense. Of course, it's not super common that you need that, but it's good to know that you could do it. In the next video, we'll actually use some of those attributes. And like I said, the most important ones are hit total and to an extent also hit num. And we will look at how we can use that to create new points on impact in the next video, which is about pop replicate. But for now, we have seen at least that there are hit attributes and some examples of what you can do with this. So I hope this is helpful. Thanks very much and see you later. Cheers.